there are certain parts whereby you do not understand. Make sure that you raise up your hand, and then we discuss everything in more clear detail. So now, today we're gonna do trigonometry, and I'm gonna do the problem solving. So remember, meanwhile, when I solve this question, I will try by all means again to go through the basics so that we can simply understand how the concepts actually unfold. So now let us start with question number 5. It says to us, do not use a calculator for this question, but I doubt people, they wouldn't be using a calculator, but for sure we're gonna use it at some point, but be smart when you use it. So 5.1, it reads as follows. It says to us, given cos theta is equals to -1/3, and theta, it's an angle that exists within this interval, which is between 0 degrees and 180 degrees, whereby 0 degrees is included and 180 degrees it is included. And then the statement again, it says to us, determine with the aid of a diagram the value of the following 5.1.1 as well as 5.1.2. So now, before we can perform these calculations, it's very important for us to know how to draw a diagram. So the diagram that they are referring to, it is a diagram that we're gonna draw on our Cartesian plane before we can solve 5.1.1 and 5.1.2. So that means I'm gonna start by drawing a Cartesian plane. Which is a plane that's gonna help us to draw our diagram that we are most definitely going to utilize to further the calculations. So now when you draw a diagram, this piece of information is very important on how are we going to construct our diagram. That means you're gonna draw a right-angled triangle. So now they say to us cos theta, it's a -1/3. And then in order for us to draw a diagram, guys, like I say, this piece of information is very important. So now when we draw angle theta, it's either we're gonna draw our angle theta on first quadrant or second quadrant or fourth quadrant or third quadrant or fourth quadrant. So now which quadrant are we going to take? Now let's take this information. So now they say to us theta is between 0 degrees and 180 degrees. So this most definitely it's 0 degrees and most definitely this is 180 degrees. So they say theta exists within these two quadrants, okay? That means from this information only, which is this one, they say to us theta exists between these two quadrants, which is first quadrant and the second quadrant. But the thing is, we can't choose two quadrants. We need to only focus on one quadrant. So how are we going to do that? So remember, it's either we take first quadrant or we take second quadrant based only on this information where they told you theta is between 0 and 180 degrees included. Now, in order for us to finalize our quadrant, we're going to utilize this information once more again to determine between the two quadrants, where are we going to draw our diagram. And they say to us cos theta, it's a negative number, okay? It's -1/3. For now, I'm not interested on 1/3, but I'm only interested on the sign provided to us. So they tell us cos theta, it's negative. So between these two quadrants, where is cos negative between quadrant 1 and quadrant 2? We know that in first quadrant, all trigonometric functions or trigonometric ratios are positive. So on first quadrant, when you talk about the cast diagram, normally we say all stupid teachers complain, which is cast. Okay, which is cast diagram. So all trigonometric function in first quadrant are positive, sine is only positive in second quadrant, and tan on third, and cos on fourth. So that means any trig function on second quadrant, which is not sine, it will be negative. That means in second quadrant, cos is negative, tan it is also negative. So now here they say to us cos, it's negative number, meaning our cos is negatives. So between these two quadrants, we know that cos, it is most definitely negative in second quadrant. That means the first quadrant, we're not gonna use it. So in order for us to draw a diagram, we're considering to draw our diagram on second quadrant. So now when you draw a diagram, like I said, we're gonna draw a right-angled triangle, okay? We're gonna draw a right-angled triangle. Now, so now to draw a complete right-angled triangle, we're going to utilize this information once more again, okay? So we are given that cos theta is equals to -1/3, right? So now remember, when it comes to trig functions, sometimes people tend to forget what am I going to write? What is cos? Is cos x over r, or it's y over r? Tan, it's x over y, or y over x. I understand. Some people tend to forget that, but so that you do not forget, this is what I like to do. Okay, quickly just draw your right angle triangle, which is simple as like this one, and then here it's your x value, and then there will be your y value, and therefore this will be your theta, and then this is perpendicular, and therefore here we have our r. So now, in order for us to remind ourselves of cos it's either x over r or y over r, this is what we are going to do. Use your SOHCAHTOA, okay? So on this right angle, the triangle. So that means, what is sine? We know that sine theta, if I were to determine sine theta based on this right angle triangle, according to SOHCAHTOA, it's opposite over adjacent. So my theta, it is opposite to side y, and our hypotenuse will always be opposite to 90 degrees. That means sine theta, it's y over r. And then that means cos theta will be how much? According to this diagram, once more again, will be adjacent over hypotenuse. So this angle, it is adjacent to this side. So that means it's x over r, and therefore tan theta will be equals to how much? To r, it's opposite over adjacent. So this theta is opposite to side y and adjacent to side x. So that means here we're going to have y over x. So now this is what is happening. This is what you do if you forget whether cos it's x over r or y over r. So now we know that cos, it is x over r. So after drawing this diagram, we are given that cos theta is equals to -1/3, okay? So that means in this case, our y will correspond with the value of x, and our r will correspond with the value of, this is r, with value of 3, okay? For a fact that cos theta is negative, which value will be negative between these two, 1 and 3? 3 will always be positive, since, well, it is our hypotenuse. That means our x, it's a negative number, which is 2, because our x, it is in second quadrant. So when we feel this diagram to be complete, that means our x here from this position to that position will be -1. And therefore, our r, which is hypotenuse, most definitely opposite to 90 degrees, will be +3. That means we left with the value of y. How are we going to determine that? By using Pythagoras theorem, okay? So that means to determine the value of I, we're going to say y is equals to root of what? R squared minus, sorry about that, r squared minus x squared. Therefore, that means our value of numerical value of r in this case is +3 to the power of 2, subtract our x is -1 to the power of 2. So now simply you can just punch this on your calculator without wasting any time, okay? So that means it's going to be 9 subtract 1, which is root of 8. And therefore, what is the root of 8 in a simplest set form? Let me see. It's 4 multiplied by 2. That means it's going to be 2 root 2. And therefore, this will be the value of y. And therefore, you plug your positive value of y there. And then again, guys, I want to emphasize on this, okay? So when you introduce root sign on both sides of the equation, here you include plus or minus. But our y, we know our y can be negative or positive. But for a fact that our y, it is in second quadrant, therefore we're going to choose positive y value to be 2 root of 2, and therefore our diagram now, it is complete. So to solve 5.1.1 and 5.1.2, it will be much more easier because we know the diagram now. We have determined the diagram now. So now let us try to solve 5.1.1. So 5.1.1, it says to us, okay, let me write it here. 5.1.1, it says to us, determine tan 180 degrees plus theta, okay? So it says to us tan 180 degrees plus theta. We go back. So now here, what is happening is we have angle theta, okay? We do not have angle 180 plus theta. We have only angle theta. So in order for us to determine theta based on this expression, How are we going to determine theta based on this expression? We apply the reduction formulae, okay? Now, this is where you need to understand the basics of your mathematics when it comes to trigonometry, okay? So now that means in order for us to do this, 180 degrees plus theta, it is an angle which is situated in what quadrant? Okay, so let me try to draw my mini Cartesian plane over here. So this is 180 degrees. Sorry, this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And then our last one cycle will be 360 degrees. Now, 180 degrees plus, it is in which quadrant? On my Cartesian plane. 180 degrees plus, it will be in third quadrant, okay? Because 180 plus, it's greater than 180. That means it's supposed to be on third quadrant, okay? So now in third quadrant, we're gonna say 180 degrees plus, it is in third quadrant. And therefore, what is the sign of tan in third quadrant? Remember, we have already discussed the cast diagram. So that means tan in third quadrant, it's positive because this is where it belongs. All stupid teachers complain. Teachers for tan, that means tan, it's positive in third quadrant. So that means when we apply the reduction formulae, we're going to say this corresponds with tan theta, okay? Positive tan theta, not in negative tan theta, because tan is positive in third quadrant. And therefore, now we can simply determine the numerical value of tan theta using our diagram. So we go back to our diagram, we are going to determine tan theta. So we're going to use SOHCAHTOA. TOA, that means it's for tan. So what is tan? Remember, tan in this case, we said it's, where is it? We said it's y over x, okay? That means tan theta from our diagram will correspond with x over y, right? And therefore, let's go back once more again to our diagram. Sorry, y over x. It's y over x, not this. It's y over x, okay? Tan, it's y over x. Now we go back to our diagram. What is y over x? Our y, it's 2 root 2, okay? And then x, it's negative 1. So that means we have 2 root 2 divided by our x, which is negative 1 from diagram. Therefore, this expression will be equals to negative 2 root 2. Therefore, this will be our final answer for 5.1.1, okay? That's how we solve it. And therefore, we move to 5.1.2, okay? Whereby 5.1.2, it says to us, determine 3 sine theta minus 90 degrees, close the bracket, okay? So they want us to determine the numerical value of this expression. Now, we're going to apply the exact same thing. Now, this is what is happening, guys. When it comes to questions like this, okay, normally you are used to a fact whereby you're going to say what angle plus theta, this angle in numerical form plus theta, this angle in numerical form plus theta. So here the problem is it's theta plus or minus angle in numerical form. It's fine. If you don't feel comfortable on reading this thing, you know what you're going to do. It's simple. You're going to swap. You're going to take 90 degrees to other side and then theta to the other side, okay, to make things much more clear and understandable for you. So that means immediately when you do that, you're going to have to take negative out of the brackets. And again, I would like to emphasize on this basic. So remember this basic, which is related to what I want to show you here. So remember, when you have sine negative angle is equals to cos negative angle is equals to tan negative angle is equals to. So when you have a sine negative angle, this will correspond when you take this negative angle out of the, when you take the negative sign out of the bracket, it's going to be negative sine. Now we have positive angle. Same applies here. When you have cos, but be careful, when you have cos, cos will remain positive, okay? Even if you have a negative angle there, but cos will remain positive. And therefore, when you have tan, we're going to take this negative out of the bracket. We have negative tan, positive theta now. So this is one of the special cases of the basics that you need to always know, or perhaps to say understand. So here we're going to apply the exact same thing. I'm going to take this negative out of the bracket, and I'm going to move this 90 on the other side of the equation. That means this sign is going to be negative, because when you take negative angle, negative sign out of this, it's going to affect the whole thing, which is going to be negative. So that means I have a -3 sine, because I took negative out. I'm just going to move positive 90 degrees here because I took this negative out of the bracket. So it affected the whole trig function, okay? So therefore, this will remain to be negative. That means, okay, will be negative theta. I just swapped 90 and theta. Or you can, to avoid wasting time, guys, I know maybe you would want to swap this as -90 positive theta, and then you take the angle afterwards. It is still fine, okay? Right. Is equals to, now we have angle and angle, we have angle in numerical value and angle in this Greek symbol. So that means we're gonna say 90 degrees minus it is in which quadrant? We're doing reduction formula. We are using this expression. 90 degrees minus, it is in quadrant number 1, okay? Here it's 90 degrees, and then going backwards, we're talking about 90 degrees minus, which is less than 90 degrees. So 90 degrees minus, it is in first quadrant, okay? So sine, what is the sign? I mean the sign of, is it positive or negative? What is the sign of sine function? So the sign of sine function, it is positive in second quadrant. So this negative will remain as negative from here. So that means we're going to have -3. But now, for a fact that we have 90 degrees, this is what we call sine will change or will transform to its co-function or co-ratio. So what is co-function of sine? It's cos. Each and every time when you see 90 degrees here, just know this will transform to its co-function, which is cos. Only when you see 90, not 180, not 360. And normally we don't work with 270. We can, but you'll, to avoid making mistakes, change that 270 each and every time when you see it. So that means 90 degree again, the sign is positive, but still will change to its co-function, which is cos theta. Okay, so that means we have -3 cos theta. Now we have our angle in terms of theta. We go back to our diagram. What is cos theta? Remember, cos theta, it is x over r. You don't even have to panic. You don't even have to worry yourself, because it is already provided to you here. Is cos theta, it's -1/3. So that means you don't even need to substitute the x over r or whatever. You can just say it's -3 open bracket, because cos theta is equals to -1/3, and then you close your bracket. And therefore, when you distribute by multiplying these two brackets, we're going to have +1. And therefore, this expression, that means is equals to +1. Okay. I hope everything it is clear. Do we all understand before I move on to 5.2? Do we all understand? Okay. Right. So now we're going to move to 5.2. Okay, we're going to move to 5.2. Now moving to 5.2. Moving to 5.2, it says to us, given this expression, so our expression in this case, let us rewrite it, okay? Or before we can rewrite it, let us read the questions first. So this is an expression, it's not even an equation, okay? It's an expression. Most definitely you're gonna have to try at some point to factorize, not to factorize, to simplify this in most cases, yeah. About for 5 marks, this is a lot. So 5.2.1, it says to us, simplify the following expression, okay? That means in order for us to simplify this, we're gonna have to understand our basics from the core, okay, of trigonometry. So now let us rewrite it first. So we have sine -210 degrees divide by cos 300 degrees plus cos x plus 90 degrees divide by sine 360 degrees plus the x. Okay, I copied everything correctly. So now it says to us simplify this for 5 marks. Okay, now you do your equal sign on this side. Okay, you're not, guys, this is not equation. Don't cross multiply or whatever. We're gonna just do to show this is equals to this. So when you see expression like this, you're gonna, because the thing is, do not use a calculator for this question. So in exam, we're gonna see that you use your calculator because you're just gonna punch this on your calculator and it's gonna give you exact what we want, but it's gonna show that you use your calculator. So when you see sine, sorry about that, when you see sine in terms of angle like this, which is given in magnitude, we're gonna expand this all the times. Okay, we're gonna expand this by using the reduction formulae or by using the special angles. It only depends. So 210 is given by which other angles. 210 is given by which sum of what angles. Okay, so that means I'm going to take this negative out of the bracket because I don't want negative angle. So that means I have a negative sign. Remember the basics that we have talked about. So 210 degrees, if you want to apply, apply the reduction formula. So this is how I love to solve in this question. 210, it is an angle that you will find in which quadrant? 210. Remember, here we have 180 degrees, and then here we have 270 degrees. That means 210 will be situated between 180 and 270. So that means 210, it is in third quadrant. So when I use the reduction formula, I'm going to say 180 degrees in third quadrant plus, but it's 180 degrees plus what? So that I will be able to get 210. It's 180 degrees plus, I think it's 30, right? Let me confirm it, 180 plus 30. It's 30 plus 30 degrees. Okay, so that means 180 plus 30 degrees will take me back to 210. But remember, I have already eliminated my negative sign because I don't want to work with negative angles, hence why my sign here now it's negative. Okay, so that means we expanded this using the reduction formula. Okay, that's very important. And therefore divide by 300. It is an angle in which quadrant? This is 270, this is 360. That means 300 is it's between 360 and 270. That means 300, it is in fourth quadrant. And in fourth quadrant, I know I work with 360 degrees minus. That means I'm going to expand this. So I'm going to say I have cos 360 degrees minus what? So that I can get 300 minus 60, obvious. So minus 60 degrees, that means 360 minus 60 is going to give me back 300. Plus this one, I don't have to expand, I have to reduce it. But remember, it's uncomfortable of me and you working with X and then the angle this side. So I'm just going to swap 90 to take it to the other side of the equation. So that means I'm going to have cos 90 degrees plus X. Nothing will be impacted because this is positive. Even if there was negative, we're just going to take it out because cos will always remain positive. Divide by, and this one there is nothing, I can reduce it, but I'll choose to reduce it on the second step. So I'll just write it as it is, sine 360 degrees plus X. Now, here we expanded, we can reduce everything now, reduction formula. So 180 degrees plus, it is in which quadrant? It is in third quadrant. Now, what is the sign of sine? Sine in third quadrant is negative. That means negative sine 30 degrees multiplied by this negative number will give us positive sine 30 degrees. I hope you saw that. Divide by 360 degrees minus, it's in which quadrant? It is in fourth quadrant, 360 degrees minus. Cos, it's a positive on that quadrant. That means I'm going to have positive cos 60 degrees. Okay. Plus, let's reduce this one. 90 degrees plus, it's in which quadrant? 90 degrees, this is 90 degrees. 90 degrees plus, it is in second quadrant. Cos, is it positive or negative inside second quadrant? It's negative. That means we're going to have, be careful of this positive. We're going to have negative. Now we see 90 degrees. Remember, cos will change to its co-function, which is negative sine x. Divide by 360 degrees plus. It's in which quadrant? Remember, here we have 360 degrees. Sorry about that. Here we have 360 degrees here. So this is 360 degrees plus, and this is 360 degrees minus going backwards. So that means 360 degrees plus, it is in first quadrant, and all trig functions are positive in first quadrant. So that means 360 degrees plus, it is in first quadrant. So sine, it is positive in first quadrant. So that means we're going to have positive sine x. Okay. Right. So now they know that, you know, sine 30 degrees, it's a special angle. But this is where I say you can use your calculator if you forget, so that, guys, you don't lose marks. You don't punch this on your calculator. You rather punch sine 30 fair. Okay. That's how you can say. So when you punch this on your calculator, or if you know it by your head, it is still fine. You can use it, and make sure that your calculator, it is in degrees, not in radians. Okay. So that means sine 30 degrees in this case is equals to 1/2. Okay. 1/2 divided by cos 60 degrees is equals to how much? Leona, it's a special angle, you're supposed to know it. Okay, so cos 60 degrees is equal, not cos 60, cos, yeah, 60, not 30. 60 degrees is equals to 1/2 as well. It's 1/2 plus, let me do this. I want to eliminate this so that I avoid doing a lot of unnecessary steps. Okay, so let me just erase this. Not to confuse yourself, so you can also do this in brackets, okay, so that you can see. So positive by negative is going to be negative, and therefore sine x will cancel sine x. That means you're going to left with 1 there. Half goes how many times into half? It goes only once. So that means we have 1 minus 1. Our final answer here is most definitely going to be 0. So when you punch this on your calculator, you're supposed to get 1 basically. This corresponds with 1. This also does corresponds with 1 as well. Therefore, this would be your final answer. So 5.2.1, they wanted us to simplify the expression. Does everything make sense?
No.
Yeah?
No.
No, okay. What's the question?
The third step.
I don't know. I can't hear you clearly. Who's talking? Pablo, okay. Pablo, remember, I don't know. Last time, remember, I couldn't hear you. So do what you did last time so that I can hear your question.
Okay. Can you hear me now?
Yeah, I can hear you loud and clear.
Okay, I was asking for how did you get to the third step, because I got confused.
1, 2, 3 here.
Not that one. Asking the second one, yes.
This one.
Yes.
Okay, how I got to sine 30 cos 30. So remember,
Yes.
180 degrees plus, it's in which quadrant?
The third.
The third quadrant, 180 degrees, I give. So sine,
Yes.
what is the sign of sine? I mean, like, is it positive or negative?
Negative.
It's negative, right? So that means for a fact that sine is negative. So I'm gonna, for a fact that sine, it's negative in 180 plus. That means that negative multiplied by this negative is gonna be positive. Let's start there, right?
Yes.
The thing is, I could have done it in that way, just that I wanted to eliminate these things because, guys, be used to this so that you don't waste a lot of time in exam. So, you understand why I got positive here.
Yes.
And therefore, for a fact that sine, this is reduction formulas. So 180 plus is going to be negative. That negative multiplied by this negative is positive. And therefore, sine is going to be this angle. We're going to have sine this angle. If it was 180, I agree if it was sine 180 minus theta, sine 180 minus beta. So this corresponds with what? This one corresponds with what? It's 180 minus, it is in first quadrant. First quadrant, it's positive. That means it's going to be sine theta. 180 minus beta, 180 minus, it is in second quadrant where sine is positive. That means we're going to have sine beta. You understand these basics? Do you understand this?
Yes.
Okay, yes, that's what basically I did, just at this stage. Happy I didn't use plus. Here we have plus, not minus. Here I was just making an example. So when we have plus, remember it's going to be negative sign there. Does it make sense now?
Yes, thank you.
All right. Okay, so I move on to the following questions. Okay, so now we're going to do 5.2.2. Now, 5.2.2, it says to us, for which values of x is the expression in 5.2.1 undefined for this interval only, okay? Now, this is what is happening. When they say, this is the expression they are talking about, 5.2.1, this is the expression they are talking about. So which x values will be able to make this expression to be undefined? That means that x value, if I have to plug it here and here, that x value, this thing, when you punch it on your calculator, will be undefined. Which are those x values? I want you to determine those x values. This question, that's what it says to us. Okay, we need those x values that when we substitute that, when we substitute them here, this whole expression becomes undefined. Now, most of the times when we deal with questions like this, now, this is what is going to happen. I'm going to take this fraction, okay? And therefore, the denominator of this fraction must not be equals to 0. If sine 30 degrees, if sine 360 degrees plus x were to be equals to 0, that means our expression was going to be like this. It was going to be like sine negative 210 degrees over cos 300 degrees plus cos x plus 90 degrees plus 90 degrees divided by 0 degrees. If sine 360 plus x were to be equals to 0, our expression was going to be like this. And therefore, the whole expression will be undefined because we can't have anything over 0. If our denominator is 0, automatically this is math error. It's undefined. So that means we're going to solve, we're going to equate, to answer 5.2.2, we're going to equate sine 360 degrees plus x to be equals to 0. And therefore, we're going to solve this x. When we solve this x, algebraically, we know that the value of x that we're going to get after solving this equation, when we substitute it here, that value of x will make this whole thing to be equals to 0. And therefore, that 0 will make this expression to be undefined. Okay, so that means we're going to equate this to 0 and solve for x, but we're not going to solve it algebraically. We're going to solve it using the basics of trigonometry. So that means like we did in general solutions. So that means I'm going to have 360 degrees plus x is equals to second function of sine arc 0 plus k times 360, whereby k is the element of integers, but we are not there. We are not doing general solutions here. Sorry, is equals to, when you punch this on your calculator, sine arc 0, you're going to get 0 degrees, okay? 360 degrees plus. This is more or less of your reference angle. Now, let us determine the values of x using this reference angle, okay? So, for a fact that sine it's 0, that means it is neutral. So we can consider any quadrant to solve other solutions of x. So that means, let's say we take second quadrant. If we take second quadrant is 180 degrees minus. So that means this reference angle, I'm going to say 360 degrees plus x is equals to, in second quadrant, 180 degrees minus, okay? 180 degrees minus this angle, which is 0 degrees plus k times 360, whereby k is the element of integers. But I'll do this k blah 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 when we do the general solution, not here. And therefore 180 minus 0 is 180 degrees. Here we have x, and then there we have 360 degrees, and then I transpose 360 to the other side of the equation. Therefore I'm going to say 180 minus 360 is going to be negative 180 degrees. This is the first solution. And then the second solution, how am I going to determine it? Again, I'm going to take third quadrant, but I'm not going to do third quadrant because we know third quadrant is 180 plus. So 180 plus this reference angle will most definitely be greater than, because they wanted us to work within the interval of negative 360 and positive 360. So that means 180 plus 360 is greater than. So I'm not going to take third quadrant. And then I go to fourth quadrant. Fourth quadrant is 360 degrees minus. So 360 degrees minus still is going to give me 0 as well. Okay, how so? So that means, check, if I say 360 degrees with my reference angle is equals to, in fourth quadrant is 360 degrees minus this 0, which is also my reference angle. And therefore I have 360 degrees, because 360 minus 0 is 360, plus x 360 degrees. And therefore I transpose 360 to the other side of the equation. My x is equals to 0 degrees. This is the second solution. And therefore from the reference, I'm gonna say from this reference angle, I'm gonna transpose through 360 to the other side of the equation. So that means x will be equals to negative 360 degrees. So this is another solution. So this is my solution, this is my solution, and this is also my solution. So that means the values of x, even if you take positive 180 degrees, okay, even if when you take positive 180 degrees, even when you take positive 360 degrees. So that means my solutions of x is the element of this solution. So that means 360 degrees, 180 degrees, 0, negative 180 degrees, negative 360 degrees, 0 degrees, positive 180 degrees, and positive 360 degrees. These are all the solutions that will make this expression to be undefined. After determining this solution for you to prove, just go to your calculator and then substitute negative 360 here, substitute negative 360 here, substitute negative 180 here, 180 here. Basically substitute all of these solutions to confirm whether these x values that you managed to get, they are making sense. So if you substitute those values, you're supposed to get undefined or math error on your calculator. Does it make sense?
Mm-hmm.
Does it make sense?
Mm.
Okay. So now I have less than 1 minute. Let me do another video. Let me reschedule another new meeting and then I'll send it just now. Okay.
Mm.
Right.